Hi guys. So in this video, I will be what collection based question that has been asked to me in past 2 to 3 months which I have given interviews. Okay. So in this, I will be explaining you in depth what all questions exactly has been asked to me, and it is repeated multiple times in almost all the interviews. And you will get to see like more or less similar to this type of questions only it will be asked to you as well. Okay. So let's directly jump onto the question set and let's see what all type of question has been asked to me. So let me share my screen. I hope you can see my screen now. So in this, it will contain all set of questions that has been asked to me with respect to collection framework. Okay, so they can ask questions on this hierarchy based question, like how is the hierarchy of this whole collection framework. Okay, so you have to understand like map has been kept separately from this collection interface. So first comes iterable, which is the parent class of collection class. Okay, and within the collection interface, sorry, collection is an interface. Okay, and within the collection interface, it contains list, queue, and set interfaces. And within this interfaces, whatever color you can see, oranges color, no, whatever thing is written oranges color, those all are interfaces. So iterable is the interface, which is the parent interface. Collection is the interface which extends iterable interface. Then list, queue, and set interfaces extends collection interface. Okay. And then within that list contains array list, linked list, vector, stack. Okay. Queue contains priority queue, DQ, array deck. Okay. So priority, DQ, array deck. So these are classes. The deck is a interface. Okay. Then HashSet, linked HashSet, which implements set interface. Then sorted set interface extends set interface. Then tree set is a class which implements sorted set interface, which in turn extends set interface. So like that, it's a hierarchy of whole collection framework. So coming to map, so map is a part of collection framework, but it is not being kept as a part of collection interface. So here also question can come as why. Why map has been kept as a part of collection framework, but not within collection interface. So because the setting of data, because the hierarchy or the implementation of map to add the data into that is in the form of key value pair. So no other operation of add and setting the values in case of this collection interfaces is not similar to that map interface put method. Okay, so map is having put method which accepts data in the form of key value pair based upon hash code and equals overridden implementation functionality. Based upon that, there is a separate implementation on map which is not there in case of collection interface. Within that set interface is there where we are adding the data and it is getting added as a key in the hash map, but still it doesn't have the exact value set. Okay, it will only be set as a key. But map is having a key value pair format. Okay, whatever you are trying to add, first of all, it will be checking the hash code value of it to find a bucket, and then it will find a it will check the equality condition with equals method, and then it will set like where exactly the data needs to be set in the form of key value pair, which in which bucket. Okay, how it will be structured. So there is a different altogether implementation for map. So this first a question that can be asked. Any question that can be asked with respect to this hierarchy. Why tree set is used? How? What is the importance of that? So I should go through each and every part of this class and interface. Next comes collection interface versus collection framework. What's the difference between that? So just now I told collection framework is a whole set of interfaces. It contains collection interface. Okay, it contains iterable interface. It contains map. Everything will be coming under collection framework. Collection interface will contain only list, queue, and set, and all the implemented classes coming into it. So here is a set of implementation differences between the two with respect to definition, purpose, with respect to framework, extensibility, core methods, and with examples. So you can go through it once. Okay. So you will get the idea of it. What is the purpose? It defines the core behavior. Collection interface defines the core behavior, but collection framework provides the unique architecture for manipulating the collection objects. Okay. So with respect to framework, it serves as a foundation interface, okay, upon which the entire collection framework is built. Okay, without collection interface, collection framework will not be existing. Okay, and collection framework contains various set of collections like collection is there, collection interface, which is coming under collection framework. Then list, set, map, and the implemented classes, everything will be coming under collection framework. Extensibility means it allows the developers to create their own custom collection types by implementing their separate methods. And in case of collection framework, it offers a different wide range of collection classes and its interfaces for their specific use cases by using list, set, map interfaces. For core methods, it includes method for basic operation like add, remove, checking the size, like is empty or not. Those specific inbuilt methods are present. And collection framework, within that, for sorting these collections.sort, there are a lot of internal methods that can be implemented. Okay, for adding, removing, everything it is there. And examples, it's already told, array list, linked list, HashSet, HashMap will not be there. You can remove this. Okay, so it's been wrongly printed, so it should not be there. HashMap will not come over here. Okay, HashMap is not kept as a part of the collection interface. It's part of collection framework. Okay, so in case of collection framework, it will come list, set, map, queue, stack, iterable, iterator. Okay, everything will come in this. And their own implemented classes also will come into this. Okay, so next. Collection versus collections. Okay, this is also very important to understand. What's the difference between collection and collections? So if you look at it closely, we need to define the purpose first. So what is the purpose of defining the collection? It basically represents a group of objects, a collection of objects. Okay. And in case of collections, it's a utility class. Okay. It's a utility class which contains certain set of methods to perform its operation, and it comes under Java collection framework. Okay. With respect to definition, if you see, collection is an interface. Okay, in the entire Java collection framework, collection is an interface, whereas collections is a utility class which is present in collection framework. Okay, with respect to usages, collection is used to define the behavior. Okay, that all collection types must implement. Okay, it defines certain behavior for the collection types to implement. Then collections it provides utility methods, okay, such as collections.sort. Okay, and there are different set of mechanism and different set of methods present within collections class, which you can use it directly to sort the data, okay, to search the data, and for other type of operations internal, you can use that classes methods directly, collections method directly, and then you can provide the operation on that. So if you are using for comparison purpose, you can directly make use of comparator within that collections.sort. So there are a lot of features that has been passed in collections class. Okay. With respect to relationship, collection interface, it serves as a root interface in collection framework. Okay. So without collection interface, this list, queue, set, map, list, queue, set, these three things will not be coming. And then we will not be able to implement those array list, HashSet, reset, those things we will not be able to implement. So collection comes as a root framework for all the implemented classes, which is coming under collection. And for collections, it acts as just as a helper class. Okay, it doesn't work out as a root of anything. It will work like a normal class only. Okay, which contains certain static methods, which is being called directly by this class name. Okay, collections.sort. So with that class, you can directly call the static methods. And then collection contains some core methods, okay, for basic operation like adding, removing, deleting. For example, you are making use of list. Okay, so within that, you can make use of array list as an implementation class. And from that array list reference object, we can call add method or remove method. Okay, and then you can remove the elements out of it. Okay. And for collections, this contains static methods. So we are directly calling to static methods from the collections class. And examples, you already know, collection is list, queue, set. Collections are collections.sort, collections.shuffle if you want to shuffle the elements. So these are the few differences that you must know, because questions can be asked out of these only. They can directly ask questions like, what are the examples of collection? What's the basic difference between collection and collections? Okay. What with respect to usages, what's the difference between collection and collections? Okay, so those things they can ask, like with respect to certain feature they will pick, and then they will ask questions based upon that. Okay, I hope you got it. Next comes difference between stream and collection. Okay, this is also a very important question. What's the difference between stream and collection? Like it has asked to me around 4 to 5 times in interviews. Okay, So this comes a very important question. So with respect to definition, it stream represents a sequence of elements which basically supports functional style programming. Okay, so basically we are using lambda function over there. That means lambda function means what? You will be having one interface which contains one abstract method. So that will be a functional interface, not a normal interface. Okay, so you know the difference between interface and functional interface, right? Functional interface contains only one abstract method, but interface can contain n number of abstract methods. Okay, it can have like n number of default and static methods as well. But one functional interface will contain only one abstract method, and it may contain n number of default and static methods. So that concept should be very much clear. So with respect to definition, stream works upon functional style programming. Okay, it works upon functional interface. For collection, it represents a group of objects which are known as elements with basic functionalities are there. With respect to usage, stream performs aggregate operation on a sequence of elements. So there will be sequence of element coming. We are doing the stream operation on it. So you are doing flattening, flat. You are using filter. You are using map. You are using flat map. You are using so different type of operations you can perform on streams. A collection, it is used to store, retrieve data, manage group of elements. Those things will be coming. For data processing, it follows functional programming. For collection, it generally follows imperative or traditional programming approach. Okay, so where you're not exactly following functional approach, rather you are using their own programming approach, like imperative programming approach. Okay, so it's like it will follow a normal traditional approach. Okay, where you are writing normal for each loop and you are doing writing business logic in that. So it follows that. So there is a list iterator, a specific iterator for list, for set. Okay, so you need to follow that approach. With respect to operation, it provides operations. Stream will provide operations like map, filter, reduce, collect this internal. There are two type of operations: terminal operation and intermediate operation. So that also will be asked to you. What's the difference between terminal operation and intermediate operation? Okay, what is that specific feature that stream contains, which collection or any other type of interfaces doesn't contain? Okay, so basically stream is lazy in nature. Okay, so what does it mean? So it basically means like however how much intermediate operations you write, if you are not writing terminal operation, your entire stream operation will not be of any use. Okay, it will not execute. So this is very important question. So stream will only work if it is terminated with an terminal operation. Okay, so if the stream operation is not terminated with terminal operation, then whole stream, whatever you are writing, 10 lines of streams, it will not work. So this is very important concept which makes it different from the rest. Then with respect to immutability, this is also very important. Stream promotes immutability. It doesn't hold the state of the object. Okay, so whatever changes you are making into it, it will create a new instance and then you are storing it in a new set of collection. Like you are doing dot collect collectors dot to list or collectors dot to set. It will create a new collection object and it will store the data into it rather than making changes into the existing collection. So that means stream maintains the immutability. But with respect to collection, it allows mutable operation directly on the source. So particular whatever source is coming, like list, set, queue, whatever is coming, it will directly modify that source. And then you can see like that source data gets modified. But with respect to streams, it is not the case. Okay, so you will see like you are modifying the source, but that data will not get modified if you are not storing it in a separate object of that list. So that is the way. Then lazy evaluation, I've already told you, stream is lazy in nature. Unless you are writing terminal operation, the entire stream operation is of no use. Then with respect to iteration, stream uses internal iteration operation, like you are using analyst dot stream dot for each. Okay, then you are writing certain thing like system dot out colon println or x lambda function. You are writing their functional interface it is having. It accepts the data. Okay, so it will have accept method. So it will take the input and return the output. So internally logic is hidden. You will not be able to see what actual iteration is going on internally for stream. But with respect to collection, you are making use of for each separately to set the data, to take the data from the collection, storing it in an object and then utilizing it in a logic. So you can visibly see the actual iteration within for each in collection. But in stream, you can't be able to see that. It is actually that logic is hidden within the stream operation. So this is important. Then next comes fail fast versus fail safe. It is like out of 20 interviews, 18 interviews, 17 to 18 interviews, I have seen this question has been asked to me again and again. So this is very important. Okay, you should know it by heart. What is fail fast and what is fail safe operation? So With respect to coding also, they can ask, can you implement and write the code based upon this? Can you implement fail fast iteration? So basically you want to see like whether you are able to write a code which throws concurrent modification exception or not. Because fail fast means what? You are trying to modify the existing iteration process based upon whatever collection you are using, and then you're trying to modify the iteration process. Okay. So in that scenario, concurrent modification exception can come. So during that concurrent modification exception, it is failing the iteration process. So it is fail fast. And to resolve that issue, we are making use of fail safe operation. So with respect to array list, is copy on write array list, copy on write array set we are using. For map, we are using concurrent HashMap. So these are the ways with which we are doing fail safe operation. Okay. So with respect to code, we will see like how fail fast and fail safe operation is working. Okay. So let's see that. So let's jump onto the code and see it once. So if you see here, I've created one set here, set of string, and we are passing string values here, 1, 2, and 3. And we are doing certain set of operations. So basically, if you see, there are three type of remove operations present. Okay. So there are three ways through which you can make use of this remove method. So first is a direct remove operation. So it is like safe operation. There will be no issue in that. Okay. So you can directly remove the particular element from this set. So there is no issue with that. It's a fail safe operation. Then there's another way of iterators remove method. Okay. So if you are making use of remove method, which you are using for iterator reference, like you have created iterator string iterator equal to set dot iterator. So this is the way of iterating through the entire elements of that set. So you can make use of for each also, you can make use of iterator also, it's up to you. But basically with the help of iterator, you will get to know like how data is being processing one by one. Okay. So there's an iterator which starts at the initial value and then it will go next. So while iterator dot has next, what it will do, it will basically check, it will return me the boolean value. It will check whether there is a next value present or not. It will check. If it is present, it will go inside. And then it will fetch that next value data and will store it in the element string element. Okay. And it will check whether the element is present or not. What element is present? So it will check 2. Yes, 2 is present in the element, then we are removing it. So basically we are removing with the help of iterator reference. We are calling the remove method from iterator reference and we are removing that particular element. Okay. So it is also a fail-safe operation. So why this is a fail-safe operation? Because it is not disturbing the state of this entire iteration process. So the iterator is happening, you are creating the object of iterator, then you are iterating through the entire elements of the map, and then in between you are trying to disturb the flow. Okay, but somehow then concurrent modification exception comes. But here you are making use of iterator reference to remove the element. Okay, so you are not disturbing or interrupting the iteration flow. So here iterator dot has next is flow. Iterator flow is there. Okay, so that is having their own flow, and the iterator dot remove method present within iterator. Okay, we are using iterator reference. We are not using collection reference. So there are two ways of removing the element. Either you are using through iterator reference and removing the element, and second way is you are directly removing you are calling the remove method on collection object. Okay, so there are two ways. If you are making use of iterator reference, it will not throw concurrent modification exception because it is fail safe operation, because it has its own state maintained. It doesn't disturb the current state of flow for this iterator. Okay, then next comes when you are trying to directly remove the element from the collection interface, from the collection implemented classes references. So here you are using set. So set is basically a HashSet reference you are using, and then you are directly trying to modify the collection. Okay, so set dot remove means you are trying to reduce the number of elements from the set. Okay, so basically here you are making use of iterator. So in the existing collection, you are not disturbing the existing collection, right? You are not disturbing the set by reducing the number of elements, but here you are reducing the number of elements within the set. So there's a difference between that. So this is very much important. So here you are trying to remove the element from the set, so it will throw concurrent modification exception. Okay, so I will show you one by one. So first of all, I will comment it out till here. Okay, and then I will show you what is happening. So here 1, 2, and 3 is added into a set. I will run it now. And here it is printing me 1 and 3. So it's working perfectly fine. It has removed 2 here. So it's fail-safe operation. So now I will comment it out this one. And then I will uncomment this one. And let's see what is happening. Here I will import. And now let's run it. Yeah, it is also working perfectly fine. It is matching the element which we have to remove, like 2. It has matched. So we are making use of iterator to remove that element. We are not directly working on the collection object. Okay, so it's a fail-safe operation because iterator maintains its own state. It is not disturbing the current flow of that state. Okay, so here there is a current flow which is going on, and the iterator maintains its own state, which is not disturbing the existing current flow. So that's why it is a fail-safe operation for here, and it will not throw any kind of exception. Okay, so it's fail-safe now. So now I will comment it out this one, and then I will uncomment the below one. So let me import it once. Okay, it's imported. So now let's run it now. Yeah. So here you will see concurrent modification exception is coming. So why concurrent modification exception is coming? Because here iterator is maintaining the state once. Okay. Let us set state.iterator. We are iterating through the entire elements of the hash set one by one. And then you will see here it is trying to remove the element from the set directly. Okay. So here we are not disturbing the current state of this hash set in iterator. But here we are removing the element from the set directly. It is modifying the structural behavior of the current collection, which is set interface. Okay, so set is having their own implemented classes hash set reference, and that reference you are using to modify. Okay, so it is actually modifying the existing collection reference. That's why if you are trying to structurally modify the existing collection while the iteration is going on, it's in progress, and in that scenario, it will throw concurrent modification exception. Okay. So this is the way that we can implement concurrent modification exception. I hope you got the clarity on this. So let's jump on to the next question. So this is already completed. So fail fast, fail safe. There is a notes written for you. Okay. So you can go through the notes. So we'll get more clarity on this. And I have shown you practically as well. So it will be helpful for you now. Next question. Yeah. So fail fast, I already told you, it directly interacts with collection. So it throws concurrent modification exception, but fail safe operates on a cloned or snapshot of the collection. Okay, it doesn't work on the exact that same collection object. So that's why it doesn't throw concurrent modification exception. Okay, it works on the iterator. Iterator creates a clone snapshot of the collection. So that's why it becomes fail safe. So arrays versus array list. This is also very important question that has been asked to me. Okay. So this has been asked to me in Publicis Sapient interview. So this is very important. Okay. So array is having fixed size, you already know. It cannot be changed one set. But in case of array list, it dynamically changes its size at one time. Okay. So it will check like it is having certain load factor. As soon as it reaches that load factor, it will double its size. So it will increase its size at a runtime. So that is a property for array list. And type wise, if you see, array can store both primitive type and object type. Okay, it is not restricted to certain type. It can store both, but array list can only store objects. It will not store primitive data types. Okay, arrays can store object, it can store primitive types. Okay, but array list cannot store primitive types. Okay, primitive type which is there, it must be auto boxed. So if you know the wrapper class property, there is certain thing called as auto boxing, auto unboxing. Okay, so those things you should go through it once. So it can only store objects and it will not store primitive type. With respect to performance, arrays are faster because it is working on indexing, and indexing makes it faster. And there is direct memory access. So it is becoming more faster because of that. And array list is slightly slower, okay, because there is some additional overhead operations based upon that. Okay, so it dynamically increases its size, and whenever we are trying to search it, and if it is there at last index, then it will take a lot of time to reach there. So there is additional overhead expense for that. That's why array list is slightly slower. With respect to memory overhead, array is lower memory overhead because we are already knowing what are the size and where exactly that element can be present. You can iterate and go there. In case of array list, it is higher memory overhead because there is dynamically resizing happening. Okay, in array, it is having fixed size. Whatever size given, we'll be using that. It's done. In array list, there is a specific size. After that, when it crosses that load factor, it will double its size at runtime. Then again, we have to create a copy of that existing array, because array list, it internally making use of dynamic array, right? It is making use of array only internally. So first, it will check like what's the size of the array created, and as soon as it processes that load factor, it will create another array of double its size and copying the element from the previous original array to the new array. So it's like it's a new set of overhead tasks that has been created. So that's why it is a little bit more time consuming. Okay, performance wise, it's a little bit on a lesser side as compared to array. So it's told that if you know the size beforehand, then always you should go for array. But if there is a case that you are not knowing how much is the size of the array, then it's better to go for array list. It will be useful. With respect to syntax, it requires more manual management. Okay, how will you create? How will you define the array? What size you have to put? So those all things are manual. But in case of array list, it has a lot of inbuilt methods. Okay, and then you don't need to provide size, like how much size you need. Those things are not required. So that way it is beneficial basically. Okay, it has a lot of built-in methods we can make use of directly. Okay, we can set the data at a specified index, we can remove the element. Okay, we can add the element, we can check the contains part, like data is present or not. There are a lot of inbuilt method. With is empty method is there to check whether data is present or not. So those things are not present within array. For every operation that you can see to add element, remove element, contains those things, you have to write your own logic. So that creates an added advantage for that. Okay. Then with respect to ease of use, array is less convenient when it is dynamically up. When there is some dynamic operation, when you don't know how much size is sufficient enough, then array is less convenient. So array list is more convenient and it's very much easier to manage because its size gets increased at dynamically at runtime. So that makes it more better. Okay, because when you don't know the size, array list is always better. When you know the size, arrays are better because it is faster. And when to use, already know. I already told you. Okay. Next question. Why map is not kept as a part of collection interface? So this is also very important question. Why map is not kept as a part of collection interface? So I already told you, right? So with respect to collection interface, all the operations present within list, queue, and set implemented classes will store data in one particular value. Okay, so there is a different implementation for that. With respect to add operation, remove operation, only one data is there where you are adding, removing, deleting those things. Okay, but with respect to map, you are putting the data, you are adding the data into that map, but there's a different operation which is going on in the backend. Okay, so first it will check for hash code, whether that hash code, which particular bucket or index it is pointing. After that, there is a overridden equals method that is implemented. Based upon that, it will find the key, whether the key is already existing or not. If it is already existing, then it will not be able to put the data because it's already present. Okay, but there can be a chance that multiple keys can have the same hash code. So then what will happen? It will create a chain of nodes in the form of linked list. So those things, there's a separate set of implementation present for map. So that's why map is not kept as a part of collection interface. Next question comes, when to go for array list and when to go for linked list. Okay, so this is a very common question which is most frequently asked here. So when we should go for array list, when you should go for linked list. So you should go for array list when there is a search operation is there, frequent search operation you have to perform. Then it's always better to go for array list because it works on indexing, and indexing is faster. Okay, and in case of linked list, it works upon the memory allocation. It doesn't work upon indexing. So node is present. So one node can be here, another node can be anywhere. So those nodes are interconnected with each other with respect to address reference. But that is not happening with the help of array list. Okay, in array list, it is internally making use of array only where each element is connected with respect to indexes one by one sequentially. But in case of linked list, it can be present, nodes can be present anywhere. So those nodes are connected with the help of memory references. So one node can be here, another node can be here. Okay, so another node can be here, but the next of first node can be the second node, which is at last. Okay, and next of the last node can be the third node, which is somewhere here. So those are not sequential arranged. They are not sequentially arranged, but they are connected with respect to the memory references. So that makes it different. Okay, so whenever you're trying to do some update operation like insertion operation, delete operation, and delete at a specified index, insertion at a specified index, what those type of operation, linked list is much better. It's much faster. Okay, because they will not try to change the index, because if you try to add the data or delete the data using array, it will disturb all the indexed element one by one. It will check the data, it will change. Okay, as soon as it finds that this element is present at the nth index, so all the data prior to nth index needs to be shifted. Then only that particular data can be added or removed. So you can see, like, if there's 1,000 elements and we are trying to delete 999th index element, so you can see like how much data shifting can be happening in case of array. So that will not happen in the case of linked list. In linked list, directly you can change the next node's address pointing, and then you can directly set the reference back to the prior node. So you can directly do the linking operation, and other nodes will not be disturbed. So that way, when you're trying to do insert and remove operation like and manipulation operation, the linked list is always better, far better. Okay, so depending upon use case, where exactly you want to use, based upon that, you can that changes. Next comes how to operate over list and set interface. Okay, so there are various ways to operate. For list, there are certain methods you can use, like add method is there, remove method is there, contains method is there. So for list, there is a specific set of iterator, which is list iterator is present. Okay, so you can make use of list iterator, and you can iterate through all the list elements. But with the help of set interface, there is nothing called as set iterator. There is a specific iterator. Okay, so you can only make use of iterator to iterate through each and every elements of the set, and then you can do the remove operation or add operation. Okay, so I've already told you iterator reference, if you use, it will call the cloned operation of that existing object, so it will be fail safe iteration. Okay, so those things will be there. Then these are a few examples like how you can do iteration, like for each loop you can make use of. Okay, or with the help of iterator you can make use of to iterate. So with the help of for each loop, you can see directly you are taking the data from the list, storing it in integer reference and printing. With iterator, I already told you list.iterator, while has next condition true, it will go inside, take the next value, print it. Then for loop with index. So if you don't want to use for each enhanced for loop, you can make use of normal or traditional for. That also will work. So then you should know the get method to get the elements from the list. Then you can make use of stream also to iterate through the entire elements of the list. Okay. Then for set, you can call set of integers. Then you can make use of a hash set. You can add array list data into it. Okay. Then for set also, same steps will be there, whatever you have followed for list interface. Okay, same set of methods, iterator, next, everything will be same. Okay, so in the case of a list, just you can make use of list iterator. In case of set, you cannot. That's the difference, but rest everything will be more or less the same one. So next question means how remove operation works in collection. So this I already told you while we were discussing about fail fast and fail safe iteration. So there I already discussed this question. Internal implementation of HashSet. Okay, this is also very important. So here, actually, we all think like first we should learn collection interface, then we will go for map. No, it's a bad idea basically, because HashSet internally implements HashMap. So if you don't know HashMap, you will not be able to understand HashSet. You will not be able to understand why HashSet preserves the uniqueness. It maintains the uniqueness. Okay, how it does that. So if you know HashMap now, or you have read it, you can go through the introduction of HashMap, like how it works and how internal implementation works. You should go through that once. Then you will get to see, like in HashSet, it internally implements HashMap. When you are trying to add the data into the HashSet, so if it is of string type, there is no issue. It overrides hashcode and equals method. But if it is of any other object type, like employee, student, then you have to provide the hashcode and equals overridden implementation for it. You have to provide, like, based upon which field you need to implement the equals method or hashcode method. So based upon that logic only, those hashcode and equals method will work. Okay. So that concept you should be very much clear about that. Then what will happen? There is a HashSet.add you are writing, whatever data you are trying to add, it will be added in a key, and key is immutable. Okay. You should maintain the immutable properties, and value will be the present, which is the default static type data. Okay. Private static default type data is there, which is of present, which is basically a dummy type data. And that if data is null, that data will be added into the set. If that data present is not null, that means data is already present. It will not be trying to add the same data again. So basically hashcode and equals method is there. So you have to write a logic based upon that, it will check. Because if you are not writing hashcode and equals method, then what will happen? If you are trying to create two employee objects, employee E1, employee E2, both are having the same set of data, like employee E1 equal to new employee, you are passing EMP101 Dev and salary, something 30,000. Then next you are creating the next set of object, employee E2 equal to new employee 101, same name Dev and 30,000. When you will try to add these two data into the set.add E1, set.add E2, then what will happen? Both employee objects will be treated differently. Although you are knowing logically that those two employee objects are same, but if you have not overridden hashcode and equals method properly, then HashSet will treat those two objects differently. And then you will calculate a size with the help of size method. You will see it will come as 2. But actually, if you see logical wise, it should come as 1. So that's why it's told to us, like, we should give proper overridden hashcode and equals logic so that it doesn't count it as two different employee objects. So that is very important. Hashcode and equals method overridden process. And it is asked in almost all interviews. How will you override hashcode and equals method? How will you provide your custom logic to implement your own hashcode and equals logic? So that is also very important. Next comes, what is the value part of HashSet after adding data in set? So I already told you it is a present, okay, present. Okay, it's like dummy data, static final type data is there, which is being set for the particular key, which is the actual value which is getting added into the HashSet. And based upon that, present will get set. So once present is getting set, if you're trying to add the same data again, if I'm considering I'm making use of string which internally overrides hashcode and equals method. So if you're trying to add the same string again and again, so once present will become true, and if you're adding the same string again, the present will be already set as true. Now it is not null. Then what will happen? It will return me true, like, yeah, boss, I'm already having that element present in the HashSet. Now don't try to add again the same element. So it will not entertain. So it will only be taking that first time the data added into the HashSet of same value. So that way the value is present, okay, which is actually the dummy data. Next comes internal implementation of HashMap. I already told you. So first it will go through the hashing function. So hashing function will calculate me the hash code, which is of 16-bit data. So it will create a modulus with the entire HashSet size, HashMap size, that is 16 basically, and it will calculate the index, which will come in the range of 0 to 15. It will point to that specified bucket, okay, and then like this, it will first see the hash code value. The hash code will be calculated. Then with the help of equals method, it will check the key part content. If the key is not present, that key value pair will be stored in a specified bucket. If for that particular bucket key is already present, because equals method is returning me true, that means that key is already present, but value is different. Okay, then what will happen? It will point to the same bucket, but it will create a chain of nodes in the form of linked list. Okay, so that way it will be getting connected. So if you should know these concepts, like if there is one key with multiple values, it will override the last value. So if there are multiple keys with the same hash code, it will point to the same node pertaining to all the nodes coming in the form of linked list format. Okay. So there will be like a hash collision can occur. So this is the hash collision concept. And there is a concept of rehashing. So this is also very important. So if it crosses the particular threshold of data, okay, it crosses the threshold of, let's suppose 8 or 10 or whatever the size of the hash map, then in that scenario, rehashing will occur and all the elements, objects which are getting stored at some of the indexes, it will get stored at some other index, and then all the elements data will be changed. Okay, so that is basically rehashing. Okay, so it basically works on the load factor. So if it crosses a certain load factor, like 75% is the load factor, and that is, it will come around 12. So in 16, as soon as it crosses 12 threshold mark, again rehashing will occur and all the element nodes data will get changed. So that way it improves the performance of the hash map. Next comes different scenarios of hash code and equals method. You should know this. This is very important question they can ask you. They can ask you based upon this, like if we are making use of employee object or student object, we are not overriding hash code and equals method, then what will happen? If we are overriding hash code and equals method both, then what will happen? If we are overriding hash code and if we are not overriding equals method, then what will happen? And vice versa. Then they can ask you, if hash code method always returns 1 and equals method always returns true, then what will happen? Then they can ask you, if hash code returns 1, equals method returns false, then what will happen? Okay, then they can ask you, like hash code is returning 1, but we are not overriding equals method, then what will happen? Okay, then another scenario can be hash code we are not overriding, but equals method we are overriding, and we are checking whether it's returning true or false, then what will happen? So these many scenarios you should consider. You should have the knowledge on it, try to implement it. You will get a clarity on this. This is the different type of questions that they can ask based upon hash code and equals contract. So you should know it beautifully. Hash code and equals contract is very important. I hope you know the contract between hash code and equals. So if two objects are equal, then they should have the same hash code. But if two objects are having same hash code, that doesn't guarantee that two objects are equal. It's a contract. Next. So next question is, can you use any class as a map key? Can you use any class as a map key? No, it should have the immutable properties as well. Okay, so class overriding the equals method must also override a hash code method. Okay, then class should adhere to the rules associated with equals and hash code for all instances. Okay, it should properly override hash code and equals method. There should be certain rules. Hash code equals contract should be maintained. That is important. So the class field which is not used in the equals method should not be used in hash code method as well. Okay, so I'm telling you, if two fields you are using out of 10 fields, let's suppose are there, 2 fields you are using for equals, you should use the same 2 fields for hash code as well. It should not be like 4 fields you are using in hash code, 2 fields you are using in equals method for equalizing. It will not work out that way. The logic is not implemented correctly. The hash map will not work correctly. Okay, it will give unexpected behavior. It will show unexpected behavior. So that is actually wrong. Then the best way to use a user-defined key in class is by making it immutable. Okay, so if you make it immutable, then it will create a new reference altogether. It will create a deep copy of it. Okay, so if you know the immutable properties, that also will be asked. Okay, how can you make a class immutable? If I'm passing list and map, how will you make those two fields immutable? So those type of questions can also be deviated from here. Okay. Then also, if a class is made immutable, it will ensure that hash code and equals are not changing in the future. Okay, so those all things needs to be considered for making a class as a key in the hash map. Okay. Then map versus flat map. It's a very common question they can ask. So flat map is basically for flattening the list. It contains list of data. So you can flatten it and create, or you can add all the data in one single list. That also you can. There's separates a very large number of use cases that can have for flat map, and map is basically for mapping data. So it is not filtering, or it's not increasing or decreasing the in number of input operations. So basically it will just take the input elements, it will map the data. Like if you want to multiply each number by 2, divide each number by 2, then you are doing in 2 to the power something, that kind of thing. Basically you are trying to map the elements by taking the data from the input and trying to modify it on those input data. So you're not removing, or you are not increasing, decreasing the elements of the input operations. Whatever data is coming in the input, you are just modifying the data. That is basically map. Then how to make Java array list read only. Okay, so there is certain thing called collections or unmodifiable collection. So whatever list is there, you can make use of collections or unmodifiable list, collections or unmodifiable set. So like that, if you do, you will not be able to change that array list once created. So that will become read only. You will not be able to write anything. You will not be able to remove anything. So that is important. So you can make use of collections class static methods, unmodifiable list, unmodifiable set. How to remove duplicates from array list? It's very simple. Put it into the HashSet, and HashSet doesn't allow duplicates, so the duplicates will be removed. Okay, so like that they can ask you. And in case of streams also they can ask you, how can you remove the duplicate elements, and we need to print those elements which are coming only once. You should remove all the elements which are duplicated. Okay, so it's a homework for you. So try it out using streams. Okay, how will you print? How will you print duplicate elements only? How will you print unique elements, which is a part of duplicate and it's a part of unique? Both should be there, one type. Okay, and another type of question can be, you should remove the duplicates and I should print only those elements which is repeating only once. So three kind of questions can be coming. I hope you got three kind of questions. Okay, next comes how to maintain the insertion order along with the unique elements. Okay, so let's suppose a certain set of elements is being added into the hash set, but you should maintain the uniqueness as well as the insertion order. So you should make use of linked hash set. So with the help of hash set, it will maintain the uniqueness, and with the help of linked hash set, it will maintain the insertion order. Okay, so why we are not using array list? Array list maintains the insertion order, but it doesn't contain unique element. It will add duplicate elements as well. So linked hash set is the best example. Then here, how is weak HashMap differs from other HashMap? This is also very important question. How is weak HashMap different from other HashMap? So weak HashMap is basically works. You have to think with respect to garbage collection. So it will provide a weak reference to that object. So garbage collection will very easily see like there is no other object pointing to this particular object reference. So it is a weak reference, and garbage collection collector will come and it will mark those objects and will be stripped from the heap memory. So weak hash maps are to be used when you know perfectly that those of references will not be used further, and garbage collector will keep on looking into it and will see for a certain threshold of time. If that particular object is not being referred to by anybody, it will not wait. It will remove it at first instance. So weak hash map is very much important. Then synchronized versus concurrent hash map. So this is also a very common question that has been asked to me. Okay, so concurrent hash map is little bit faster with respect to synchronized hash map, because you know the thing, right? Synchronized hash map blocks the entire map, but concurrent hash map works upon each and every object. Okay, if you are doing read operation, then you can do multiple read operations at a single bucket at a single point of time. But with respect to write operation, it needs to create a lock on that bucket. If another thread try to modify the existing bucket, which where the current thread is has already acquired a lock, then it will not happen. It can acquire a lock on other objects, other buckets, but the existing bucket where already one thread has acquired a lock, another thread can't acquire a lock because it is already acquired. So it will, till it is released, another thread has to wait if all the buckets are occupied with some of the other threads. So this is the way where we are working on this operation. So concurrent HashMap, it includes java.util concurrent package system, which implements concurrent HashMap. And for synchronized HashMap, it implements a synchronized map. So basically, you can make use of collections.synchronized map method you can use to make the map synchronized. But for concurrent HashMap, we need to create a constructor, we need to create an object, and then you can set it for making that object as concurrent HashMap object. Okay. For concurrent HashMap, we cannot add a single null key value pair. But with the help of synchronized HashMap, we can add a null value pair, null key value pair. So it's a homework for you to find it out why concurrent HashMap doesn't allow null key or value pair. Okay, you should find it out. We'll learn a lot on this. In case of concurrent HashMap, we can perform the read and write operation concurrently in a concurrent HashMap. Concurrently, you can perform read as well as write operation. But this synchronized HashMap does not allow concurrent behavior. Okay. Then concurrent HashMap is actually scalable. So you can work upon multiple threads together at the same time. You can work upon multiple read and write operation at the same time. So that makes concurrent HashMap more scalable. And concurrent HashMap is thread safe. Okay, it is not applied in the whole object, but at a bucket level. I already told you. So with respect to performance wise, also concurrent HashMap is faster. Okay? And locking mechanism, I already told you, it requires fine-grained locking concurrent HashMap because it works upon each and every bucket. Each thread will work upon separate object, so it is faster. Iteration-wise, concurrent HashMap will have like it supports their own iterator. Okay, it does not throw concurrent modification exception. Okay, and for iteration for synchronized map, it requires external synchronization for iteration over the map. Okay, so these are the things that you should be knowing in your mind before going for the interview purpose. Okay, I hope you got a clarity on this. So these are the differences. Now next, what are the best practices related to Java collection framework? What are the best practices that you can get? So first of all, choose the right collection type. So before actually going for development, you should find it out like what collection type will be best suited for me. Like list, set, map, which one should I go for? You should provide proper generics so that if you are passing list of employees, it should not contain student type data. So provide generics. Prefer interfaces over implementation. So I've seen some people are writing array list AL equal to new array list. No, you should write list AL equal to new array list. So implementation should be for classes, and then it should prefer interface, like upcasting should happen. Okay, so that way you can promote polymorphism as well. Okay, then consider performance implication, like if I'm using map, then can there be any performance issue? If I'm using set instead of list, can there be any performance implication? So those things you should keep in mind before going for development. Then there should be like, we should make use of comparable comparator. Okay, then we should be aware of this concurrent modification exception coming or not. Okay, we should make use of appropriate data structure. So you should be exactly knowing like what all things you should implement. Okay, then they can ask you at last like, can you implement your own array list? So you should try it out by your own. Okay, you will get it. Like, how will you implement your own array list? How will you implement your own hash set? So you can go through the ArrayList class, you can go through the HashSet class, try to observe the methods present within it. So you will see like add method will be there, content key method will be there, remove method will be there. Okay, so try to go through those methods and see what exact logic has been written over there, and try to write your own logic for ArrayList. So let's suppose ArrayList class is not given for you. You have to create your own ArrayList and then you have to implement it. How will you do that? That also question was asked to me in one of the interview in HCL. So based upon that, you can get the idea on it. So try to implement your own data structure. It can be list, it can be set, it can be mapped. Try to implement on your own. Then you will get a complete knowledge of the entire data structure. Then they can ask you about time complexity of different operation. Like if there is add operation, remove operation, delete operation, what are the time complexity? You just go through that. Okay, list, queue, set, map. They are separate operations. What are the time complexity of all those? Okay, then it's done. I hope you got a clarity on this, like what all things can be asked in the interview. Okay, so I hope you got a understanding of each and everything, like what all things you need to think about before proceeding ahead with the interview. These are the basic things that you should be knowing. They can ask you. It will cover everything. Whatever I have told you, no, it will cover everything, almost all the things. Still 1 or 2% chance can be there. They can ask something new, and you should embrace the change. Whatever things you are learning new, just understand it like it's for learning purpose. It's for you only. You will get to know a lot of things. And then from here, it will directly go to streams. Streams, it will tell you like we are making use of list or set. I am working upon that. We are modifying the data in that list or set. So those all questions can come. So how will you operate with the help of streams on those lists? So you should know the streams data, internal, intermediate operations, terminal operations. Those should be very much clear in your mind. Okay. So these are the things that has been asked. So if you want to know more about what all questions has asked to me in streams in one single video, you can comment it down below. I will tell you each and every type of question that has asked to me in streams in one single video, like this only. Okay. So if you like my video, please like, share, and subscribe. And then just tell me in the comment box below what all type of contents that you want from me. I will create a similar type of video on that. Okay. So It's Devjit Roy. See you in the next video. It's Devjit Roy signing off. Bye bye.